Hi, welcome back to Mr. Silver's Math. Today is day one of talking about slope. So today we're going to focus on slope on a linear equation, but we're going to focus on figuring out what slope looks like and then how to figure it out when it's already graphed. So first off, slope is the rate of change. It's also a ratio that represents the horizontal and vertical increase or decrease of a line. Slope is represented using the variable m. And there are three different ways to determine the slope of a line: counting, rise over run, which is what we're going to focus on today, and then tomorrow we're going to focus on using the slope formula if you have ordered pairs, and if you have a table, we're going to focus on the change in y over the change in x. So first let's talk about slope. So a line has a positive slope if it increases from left to right, and over here I drew an example. A line has a negative slope if it decreases from left to right. Once again, I drew an example over there. A horizontal line has a slope of 0. So I like to think of a horizontal line as like your horizon. It's going left to right, and my slope is 0. In the word horizontal, the second letter is the letter O, which looks just like the number 0. So that's how I remember those two together. Horizontal is like the horizon going left to right, and it has a slope of 0. Any vertical line, and a vertical line is going up and down, has a slope that's undefined. Once again, I drew an example over here. So example 1 is asking you to identify whether it's positive, negative, 0, or undefined. So this is positive, it's going up and to the right. This is straight up and down, a vertical line, it's undefined. This one might be a little tough to see, but the line is right down there. It is 0 going left to right, it's horizontal, and this one is negative. So you may be thinking B and C were pretty straightforward, but how do I know what A and D are? How do I know if it's really positive or negative? Well, think of it this way. We are used to reading from left to right. We do the same thing in math. So we start on the left and we go to the right. So if we read our graph, we're starting here and going this way. Think about this. Are you going up a hill? Imagine there's a person walking. Are you going up the hill or are you going down the hill? Well, if you go up the hill, right, that's positive. You're going to a higher elevation. Here I am at the top, and I'm going down. Remember, we're reading left to right. So I'm up here, and I'm going down the hill. So I'm getting to negative slope, going down. Up is positive, down is negative. And this is just asking you to draw different examples. It says answers vary because this is not the only drawing that you can have for those. So now that we kind of know what it looks like, let's figure out what the slope is if I give you a graph. So your steps for success. Choose 2 points on the line. It doesn't matter what points they are. I just encourage you to use whole numbers. So what I mean by that is here and here I have nice whole numbers, meaning that point is at the corner of one of those grids. I don't have it in between because then I don't really know what that number is. I could guess that this is at like negative a half down 2.5, but I don't know. Whereas on here, I can clearly state and confidently state that this is at 0, negative 2. So that's what I mean by 2 whole points that are whole numbers. So you're going to pick any two, doesn't matter which. You're going to start at 1 point and count the change in y, which is the rise, and then this becomes your numerator. From there, you're going to count the change in x, which is the run. This will be your denominator. And if possible, you're going to reduce the fraction. So I picked at this point, I'm counting the rise. I went up 2, that's my numerator. From there, I went right 1, that formed my denominator. Now over here, I made a note. I didn't talk about it yet, but I made a note. The rise, if it's positive, you're going up. If it's negative, you're going down. For the run, if you're going to the right, it's positive. If you're going to the left, it's negative. So I went up, and then I went right. Because remember, I started here, and I'm trying to get to this point. I need to figure out how many up and over I went. I can only go up, down, left, or right. Can't do any diagonals. I have to go up, down, left, or right. So I went up 2 and then right 1. And it's always the rise is up top and then the run is in the bottom. So the rest of the note is asking for you to find the slope. So on this one, if there are no points picked, you pick them. I picked this point and this point. So to get from here to here, I went down 3 and right 2. Because I went down 3, that made it negative. I went right 2, which made it positive. And if I think about it, I can do a quick spot check to make sure that at least I have the positive or negative right. If this is me and I'm walking down this line, I'm walking down the hill, I should have a negative slope, which is what I have. And this is asking me to find the slope again, but now I just have a bunch of different lines. Notice that I wrote no decimals. So I don't want you to take 5 halves and turn it into 2.5. I don't want you to turn it into a mixed number of 2.5. Leave it as a fraction. Because eventually we're going to do something with that slope, whether we're going to graph it or whether we're going to compare it to other slopes. If possible, reduce. So negative 4 over 2 becomes negative 2 or negative 2 over 1. Negative 3 over 3 reduces to negative 1 or negative 1 over 1. And then here's just some true or false that you're correcting it if it's false.